Let me go ahead and do this initial value problem and just tag it at the end of that section. Let's look at a velocity initial value problem. Let's suppose a rock is tossed upward and we know its initial velocity is 64 feet per second and its initial height is 100 feet. Let's find the position function using t for time and s of t for position, and let's find when the rock will hit the ground. Well, s of t represents the position, and we know from earlier discussion that s prime of t is velocity and s double prime of t is acceleration. Okay, so since t equals 0 is the initial time, then we know the initial height is 100, so s of 0 is 100, and the initial velocity is 64, so s prime of 0 is 64. Assuming gravity acts as a rate of 32 feet per second, we know that acceleration will act negatively at negative 32. So we know that since acceleration is going to be negative 32, then we know to get, that would be the second derivative of position. So the first derivative of position, which of course would be velocity, would be the integral of the second derivative. So we integrate the second derivative with respect to t and we get negative 32t plus a constant. Well, the fact that we know that the derivative at 0 is 64, remember this derivative also represents velocity. So since we know the initial velocity at time 0 is 64, well, if we plug 0 into this, that actually should say equal, s prime of 0 equals 32 times 0 plus c1. So since velocity is equal to 64, but velocity also equals at 0 this constant, then this constant is 64. So now we have a velocity function of negative 32t plus 64. Now we can get the position function by integrating, we can get the position function s of t by integrating the first derivative, and that will get us back to the function itself. So we integrate negative 32t plus 64, and using our rules that will give us negative 16t squared plus 64t plus a new constant. And then of course we know that the height or the position of the object at 0 is 100, and you also know that if you evaluate this function at t equals 0, you're just going to get c2, so c2 must equal 100. And so now we can plug c2 back in here, the 100 in for c2, and we get that the position function is negative 16t squared plus 64t plus 100. And now we could answer a whole slew of questions, but let's just focus on the question we were asked. The second question said, find when the rock will hit the ground. Well, the rock hits the ground when the position is at 0, or 0 height, so set the function equal to 0 and then solve it using the quadratic formula. And when I did that, I got approximately 5.2 seconds for it to hit the ground. So that's what I was talking about earlier when I said you can solve for C if you have additional information given. And of course here the additional information was we knew the initial velocity was 64 feet per second, so that meant that the first derivative of position at 0, at time equals 0, was 64. We knew the initial height was 100, so that meant that the position function at 0 was going to equal 100. So that information allowed me to actually solve for those constants.